Displays in IoT. Why do we need displays in IoT? This is the first question to be answered and to be clarified. The displays eases the readability and visualization of any data like the graphs, tables and sensory data. In IoT, the source for this kinds of data is microcontroller. The question that rises immediately is, why do we need displays other than the serial monitor? This session will give you a clear idea about why do we need that. The displays can be used in the applications where you need to make some user interaction. For an instance, the kiosks present in ATM, the railway stations, the vending machines, etc. are the simple examples. Types of displays for Arduino. There are many types of displays available for IoT applications. They vary with different factors. The pixel resolution, size of the display, communication protocol used are the major factors. The type of display is chosen based on its application. The most famous displays of Arduino are 16x2 liquid crystal displays and OLED displays. Both are presented in front of you for a quicker reference. Which display is better? This session will give you a better and clearer understanding of how to choose the type of display for your application. The main factors to consider in electronics is fundamentally the cost and size of the prototype. The 16x2 LCD display has almost 16 pins to control each pixel on the display, and the size of the display is very large, but the cost of an LCD is much lesser compared to an OLED. We will be using liquid-crystal.h library for controlling the pins and the data. An OLED works on I2C protocol so that the number of pins required for data transmission is just 2. Thus, the size of an OLED display is a lot smaller than an LCD display. However, its cost and the resolution is much greater than the LCD display. But an LED has lesser power consumption compared to LCD. We have presented the controlling pins of LCD and OLED displays in front of you for a reference. Interfacing OLED and FSR. It is time to understand how do we interface OLED and FSR. Please understand and note that the VCC of OLED must always be connected only to 5 volt of Arduino Uno and not to 3.3 volt. Remember, it should not be connected to 3.3 volts. The connection diagram is presented in front of you and the table is also presented with detailing the connections. The Arduino's 5 volt pin should be going to OLED's VCC and FSR pin 2. The ground of Arduino should be connected to the ground of OLED and resistors pin 1 will be there. And A4 to SDA, A5 to SCL of OLED and A0 of Arduino should be connected to the resistor pin 2 and FSR pin 1. You need to follow the same configuration, and that's all. Once you do it, you are all set to go. Installing OLED libraries. Libraries are the collection of all explicit functions that can be used for controlling a device. There are predefined libraries to control an OLED display easily. We will be using the OZ OLED library for displaying the FSR data on the OLED. The zip file of the library can be found along with the given material or can be installed easily from the internet by the methods explained earlier. To install the library, you can open an Arduino IDE and use the inbuilt add.zip library option, or you can just extract the zip file and copy the files into the libraries folder. You can see the same thing that we have done in the screenshot presented for your reference. Now it's time to code. Include OZ OLED.h for accessing the OLED's pixels and wire.h library for accessing I2C communication, as OLED will work over I2C protocol. The FSR value n variable is used for storing the new FSR values, and FSR underscore value 0 variable is used for storing the previous FSR value. These two are the variables. The baud rate is set to 9600 and the OZ OLED.init will initialize the communication with the microcontroller. The code snippet is presented in front of you with all these details. Include OZ OLED.h. This will import the OLED header files. Include wire.h. This will import the wire library for I2C communication. I have two variables. The first one FSR underscore value n equal to 0 This is the variable to store new FSR value. FSR underscore value 0 is assigned with 0. This is used to store the old FSR value. And we have got setup where we set up the baud rate as 9600 and we have initialized the OLED display with OZ-OLED dot init. OZ-OLED dot clear display will clear the screen and set the position to the top left corner. There are different modes of display in OLED. One of them is OZ-OLED dot set normal display, which sets the display to normal mode. OZ-OLED dot set brightness is used for setting the brightness of OLED. 0x00 is for the least brightness and 0xFF is for the highest brightness. OZ-OLED dot send command is used for setting the orientation of OLED. 0xA1, 0xC8 are used for upright orientation of the OLED, and the same is presented as the code snippet in front of you for your quicker reference. Before going deeper into the coding, we should know all the commands available with OZ-OLED library. This will help us understand which function takes what type of arguments while coding. Open the OZ-OLED.h file from the extractor folder using any text editor. We have used the notepad to open this header file. You can also use Notepad++ or Visual Studio Code for opening it. You can use any such editor to read the content. We can find all the functions available within the library and we can know the arguments to be passed. This is a common practice to know all the functions available in the library, and we recommend you to definitely follow the same. You can see that the list of available functions are displayed as printChar, printString, printNumber, print big number, draw bitmap, and in the right hand side we have also displayed the function names clearly. The arguments are to be known for you to code it better, and that's a very common practice that every coder should follow. We'll go with the coding more and more right now. The code shown prints an animation of the word while the code prints each letter of the word for every 500 milliseconds delay. OZ-OLED.printString, in the brackets you can see that W, 2360. Now W is the string to be printed. The X position of the cursor is represented by the first argument after W, which is 2. 3 represents the Y position of the cursor, and the number of characters to be displayed is represented by the 16, and these values can be changed accordingly. The number of characters to be printed on the screen are set to 16 by default, even though only one letter is printed at an instance. This is a very important point to note and do not forget it. And we are sending characters W, I, L, E, Y, dot, and all these are sent one after another, and we have presented the code snippet for the same in the right hand side of the screen. FSR underscore value n is used for storing the new FSR values. As we have seen earlier, OZ-OLED dot printString method is used for printing a string on the OLED, and OZ-OLED dot print number method is used for printing a number on the OLED. We have given a delay of 500 milliseconds for stabilizing the sensor output and displaying the value on OLED. This delay is very nominal and you can try it out in trial and error method. And you can see the code snippet that is presented in front of you. In the loop, we have got FSR underscore value n, and using analog read, we are reading the FSR value. And this is all printf statements which you can see. And we are using OZ-OLED.printString FSR value, 1316. This is explained clearly in the previous slide where X, Y orientations and all these are explained with values in the previous slide. Now, OZ-OLED.print number is used for printing a number on the OLED screen, and this is the value to be printed. This is the number of digits to be printed. 12 is the X position and 3 is the Y position, and delay is 500 milliseconds for our reference. As we increase the pressure on the FSR, the value starts increasing and it will reach a triple digit value. After we remove the pressure, the FSR value drops below 100 and reaches a double digit value, and eventually a single digit value will be uptime. Once the OLED prints a digit at a place, it cannot nullify the display in that place and retains the last seen digit in that place. In order to prevent this, we need to clear the OLED display once it drops back below 100. In this tutorial, we are dealing with high pressures, that is greater than 100, and we have taken FSR underscore value n as lesser than 100. In case you are dealing with low pressure applications like greater than 10 and less than 100, you can change the FSR underscore value n as lesser than 10. Please do not forget that the range of the FSR values can be controlled by carefully choosing the resistor value which is placed between the ground and FSR pin. This can be referred from the circuit diagram, and the same has been coded very clearly in front of you for your quicker and easier understanding. Thank you. The connection diagram is shown in front of you where we can interface the FSR and OLED with Arduino. We have followed the same guidelines and we have made the demo, and you will see the same right now. As you can see in front of you, the connections are all made and it is very simple. You got to just follow the same guidelines which we have presented to you during the theoretical explanation. This is the OLED, this is FSR, and we have connected it appropriately with the resistor to avoid excess flow of voltages which would damage the circuit. So we have used resistor to make sure that nothing is damaged on board. The code that has been explained to you is presented in front of you, and this has to be uploaded into the Arduino. Once uploading is done, it's very easy for us to demonstrate how exactly it works. We are uploading it right now, and it may take a couple of seconds for you to get it compiled, and then less than half a minute for you to get it uploaded. The moment it is uploaded, you could see in the OLED Wiley is displayed, and the FSR value is 0 because we have not given any impact on the FSR, and since it is 0 there. You can see now we are going to give impact, and appropriately the value would rise. You can see that the pressure I have given and the FSR value gets increased immediately, and when I remove the hand, the FSR value got back to 0. That's it. So very simple exercise where we have interfaced OLED and FSR with Arduino, and we can read the values using OLED instead of going with traditional serial monitor. Thank you.